go to air tonight. There are blazes burning out of control around Victoria, with more houses.
It's a drought the likes of which Russia hasn't known for years.
Climate change. Fires, floods, storms and droughts ravish the earth. Such phenomena are prompting questions in the minds of the masses. Why? Governments are responding with climate change programs. Many people and organisations are acting to reduce their carbon footprint. At the back of their minds is the possibility that climate change could lead to this. If the Earth is going to become like Venus, where it is hot enough to melt lead, and any rain that falls is likely to be similar to battery acid, the Earth has had ample time to do so. Life has survived on Earth for an estimated 4,000 million years. Complex life, that is animal grade life, complex life has survived for an estimated 500 million years. During this time, presumably the Earth's vast deposits of hydrocarbons were formed. It has been estimated from the size of these deposits that the Earth's atmosphere handled quantities of carbon in the order of 600 times the current atmospheric concentration. So Earth has had ample time for its climate to go awry. Substantial quantities of carbon have been present in its atmosphere, but its climate has not deteriorated to lead melting extremes. Had it done so at any stage, life would have been obliterated. This means that the Earth's climate has been kept in an equable state, or it has been moderated in some way. So what is it that stops the Earth from becoming a hot desert like Venus, or for that matter, a cold desert like Mars? Mars does have a carbon dioxide atmosphere like Venus. One is a hot desert and the other is a cold desert, and here is the good old Earth in between. And I think we can assume that the Venusians didn't over-industrialise and produce a whole lot of carbon dioxide, and the Martians didn't over-industrialise and produce too much carbon dioxide, and thus turn their planets into deserts. There might be some more scientific reason. Let's try to get rational about this and not lose our heads and our checkbooks. Something must be ameliorating or moderating the Earth's climate. It has to be something more sophisticated than the volume of carbon dioxide or methane or other gases in our atmosphere. It has been known for centuries that the sun's magnetism is somehow linked to our weather patterns. Sunspots, for example, are a magnetic phenomenon in the sun. This is widely known. But there is something that isn't so widely known, and it has to do with the Earth's magnetism. If you dig into the geology texts, you discover that, as best as geophysicists have been able to determine, the Earth's magnetic field reverses polarity from time to time. Geology isn't always an exact science, and often the rock strata are missing or the properties of the rocks are altered. But even so, we can be reasonably assured that there is some sort of a mysterious link between the behaviour of the Earth's magnetic field in the past and past climates. And to date, this link has been completely mysterious. There's been no theory to explain it. You might wish to take a look at this entry on paleomagnetism taken from Wikipedia. You will find an animal which they call the Long Cretaceous Normal Superchron, or should I say the Cretaceous Long Normal Superchron. This animal appears as a large area of black in the column shown. If the geologic column which they show extended down considerably further, you would encounter another animal, a long white part of the column which they call the Kaiarman Long Reversed Superchron. These are the best documented and best known protracted periods of subdued or infrequent magnetic field reversal in the geologic column. They are periods of time in which the magnetic field did not reverse its polarity with any frequency comparable to other times in the geologic history. Infrequent polarity reversal. Now this could be purely coincidence, but in both instances the rock strata of these periods of infrequent reversal activity were also times of climatic difficulty. The rock strata of those periods contain a high proportion of sediments that indicate dry climate or times when there's a lot of salt deposition, indicators of difficult times on the Earth. And both, coincidentally, were followed by major global extinction events. So there is, in the geologic record, evidence of some sort of a possible link between the Earth's magnetism, or at least its polarity reversal frequency, and the Earth's climate. Here is a question for all you Einsteins and geniuses. What possible link could there be between the magnetic field and our climate? Does the magnetic field have the power to stir the elements in the atmosphere and oceans? Well, the short answer to that one is no. That's the short answer anyway. The northern and southern lights, or auroras, which I've personally never seen, are evidence of some sort of stirring, but that is a stirring amongst subatomic particles high up in the atmosphere. The northern and southern lights do not power the world's air circulation. Coming from the heavens down to Earth, if you see unexplained movement in your swimming pool, don't look for the magnetic field, but you could look for a stray duck. But now think on this a moment. If you happen to own a salt water swimming pool, salt water being a conductor, if you were to see movement in your pool, is your stray duck creating a magnetic field? The answer is yes. Gregory Riskin investigated this possibility in his paper on ocean currents and magnetism. We could look at some extracts from it if we wish. Our magnetic field is not strong enough to directly drive oceanic and atmospheric circulation. The reverse, however, is quite possible in a small way, as Riskin shows. Oceanic and perhaps atmospheric circulation could conceivably be factors influencing our magnetic field. Now, the oceans and the atmosphere do not create our total magnetic field, but they must influence it. Therefore, oceanic and atmospheric circulation could play a part in magnetic field reversal. Now, Einstein, an intriguing question suggests itself. Climate affects the circulation and composition of the oceans and atmosphere. The circulation and composition of the oceans and atmosphere affect the magnetic field. As Riskin shows, this is a mathematical certainty, and as the geologic record suggests, there is some sort of a link between climate and magnetism. Does the magnetic field, by the way in which it interacts with the sun's magnetic field, influence the heat which the Earth receives and or retains from the sun, thus providing the ameliorating or moderating effect for which we are searching?